Hey guys, it's Jesse here, and today I have a special video. It is my chemistry project on molar mass and moles. I'll be showing you what a mole actually is and defining molar mass, as well as showing you how to apply that in our chemistry equations. Alright, so first things first, let's start out with the formula for a mole. Now a mole is equal to the mass of a substance over the molar mass of that same substance. Now, I may be getting ahead of myself here, so I'm going to go ahead and give you the definition of a mole. Now, a mole, or MOL for short, is actually the amount of a substance that contains 6.02 times 10 to the 23rd representative particles of that substance. Alright, 6.02 times 10 to the 23rd particles. Now the next step is defining molar mass. Now molar mass is defined as a term used to refer to the mass of a mole of any substance. Now to me that definition isn't quite descriptive enough and doesn't really make sense. So I'm going to go ahead and give you an example of what molar mass is. So let's say an equation gives you O2. So that means that this, I hope you all know that O is oxygen. So oxygen, this subscript means that there's two atoms. So the molar mass is all of the atoms in a substance added up or summed together. So that means that we need to know the mass of oxygen, which is 16 grams. And then figure out how many atoms are of oxygen that there are, which is 2 because we know because of that subscript right there. So we'll go ahead and bring this subscript over. So 2 times the actual weight of oxygen, which is 16 grams. And then we can figure out that the molar mass is equal to 32 grams in this equation. Alright, so those are the two basic steps of this. So this also works for more complicated versions of figuring out molar mass. So if, let's say you had O2 plus C2, then you would need to figure out that, well, we just figured this one out, that the molar mass of O2 is 32, and you need to find out what the mass of C2 is and add them together. So I'm going to go ahead and give it to you right here, that the mass of one carbon atom is 12.011, and if there's 2 of them, again, we need to bring that 2 over, multiply by 2. So then you go ahead and add 32 plus 24.022. Now I'm just going to do this off the top of my head. Hopefully I get it right. So we go ahead and add the 2, 6, 20, 56.022 will be the molar mass of O2 and C2. Alright, so let's go ahead and do it in some more complicated equations. Alright, so I don't know if you guys can see that. I'll go ahead and zoom in. So the first equation states, if 50.4 grams of sodium is used in an explosion, how many moles of sodium are left to react with water? Alright, so let's go ahead and use that first formula that I gave you. So we know that a mole, which is what we're trying to find, is equal to the mass of a substance, which is given right here, mass of sodium over the molar mass of that substance. So we'll go ahead and write it out here. So we write what is given on the top left. So 50.4 grams of Na, which is sodium. Hope you all know that. We'll go ahead and write 1 mole right here because that is what we are trying to find, divided by the molar mass of sodium. So since there's only one sodium atom in this, we're going to write 23.0 grams of sodium. And so then you're going to go ahead and divide 50.4 grams of sodium by 23.0 grams of sodium. And so the sodiums are going to cancel out because there's one on the bottom, one on the top. And you're going to end up with 2.19 moles of sodium. That's your final answer. All right. So next one. So it says how many moles are present in 0.250 grams of Ritalin. So Ritalin, if you don't know, is a medicine often used for ADHD. Just a random fun fact. So what we're going to go ahead and have to do now is write what's given again. So 0.250 grams of C14 H19 NO2. That's going to be on the top left because it's what's given. Alright, so then we're going to have to figure out the molar mass of this mess. Alright, so you're going to want to bring all these numbers over, all these subscripts over to their correct atom, and add them all together. So we got 14 times 12.011 plus, plus 19 times 1.001 plus there's only one nitrogen atom, so it is just 14.007 added to 2 atoms of oxygen, so 2 times 16. Now I'm sure most of you can't do this off the top of your head, so I'll go ahead and give you the molar mass, which is 233.19 grams of C14H19 NO2. Alright, so then we're going to go ahead and write 1 mole up on top again, just because moles are what we're trying to find, and go ahead and divide 0.250 by 233.19. So the answer is 0.001 moles of C14H19 NO2. Oops. Alright, so our last problem here says how many moles are represented in 4.75 grams of water. Now this problem's a little more difficult. I would hope that we all know what water is. It's H2O if you don't, which is not given in the equation. So sometimes they might do that to you, and hopefully you either know the compound or have some sort of resource like your textbook, or maybe even search it up on the internet if you really don't know what it is, or our flashcards for the polyatomic ions. Alright, so we're going to go ahead and start on this problem. So let's write what's given up on the top left again. So 4.75 grams of H2O, aka water. Then we're going to go ahead and write 1 mole up on top, divided by the molar mass of water. So the molar mass is 2 atoms of hydrogen, so 2 times, we're going to bring this over, 1.001 plus, let's see, plus just 1 atom of oxygen, 1 times 16. And that is going to come out to 18.002 grams. So we're going to go ahead and write the molar mass on the bottom, 18.002 grams of H2O. And again, the grams are going to cancel out, leaving just the mole. And if you divide 4.75 by 18.002, you're going to get 0.264 moles of H2O. Alright, that was the last problem for today. I hope you guys understand the entire concept of moles a little bit better. Thank you for watching.